Today we are going to see the common distance matrix used in clustering. Is distance metric? Distance metric is a function that presents a method to measure the closeness of two elements. A distance metric is a function d of x of y that specifies the distance between two elements of a set as a non-negative real number. So two elements are equal under a particular metric if the distance between them is 0. Three commonly used distance metrics are Euclidean distance, that is a distance between 2 points in the plane with coordinates x, y and ab. So the formula to compute Euclidean distance is given uh, x minus a whole square plus y minus b whole square and square root of it. The second formula is Manhattan distance, which is also called L1 distance. The formula to compute is given and it takes the absolute value instead of square root. The third distance matrix is Chebyshev distance, which is defined on a vector space where the distance between two vectors is the maximum value of their difference along any coordinate dimension. For example, the distance between 2 points is their maximum distance. We are going to apply these three distance matrices on this data set, which has two variables 1 and 2. The data is about 3 persons. We compute the Euclidean distance between person 1 and person 2. We just fill up the formula with values, and the distance between person 1 and person 2 is this 18.86. Then we compute the distance between person 1 and person 3, and just having these coordinates, person 1 coordinates is this and person 3 coordinates are this. So when we fill up the formula, we got this value. Then we computed the distance between person 2 and person 3 and having coordinates this. So when we fill up the formula with these coordinates, we got the value 40.19. So this indicates that person 1 and person 2 are more similar as their distance is minimum, and person 1 and person 3 are most dissimilar. Then we computed the Manhattan distance between person 1 and person 2, person 1 and 3 and person 2 and 3, and just we fill up the formula with the values, and here we are taking absolute value instead of square root. Means if the value is negative, we will consider it positive. So as you can see that person here also, the person 1 and 2 are more similar as their distance is minimum, while person 2, person 1 and 3 are more dissimilar. Last, we computed the Chebyshev distance between person 1 to person 1 and 3 and person 2 and 3. And here we just fill up the formula and we have to take maximum value. So maximum among minus 10 and 16 is 16. So as you can see that person 1 and person 2 are more similar to each other as their Chebyshev distance is minimum, while person 1 and 3 are more dissimilar. So among the three distance metrics that we discussed, if we talk about computation, the Euclidean distance is computationally expensive, means it calculates the square root, so it is computationally expensive, while Manhattan and Chebyshev are simpler and faster. But Euclidean distance is a commonly used distance metric used in k-means, KNN, and image processing measures, while Manhattan distance measures the distance by only moving along grid lines, vertical and horizontal, while Chebyshev distance measures the greatest single dimension difference between 2 points. So these three are commonly used distance metrics uh, used to compute distance between points.